I want to show you how I create systems and rules so that I can get better and more consistent output from my AI. So whether you're using ChatGPT, or in this case, I want to show you Claude Code and how I use Claude Code so that you don't have to re-explain things like you're having a new intern every day. So basically this is a system. I want to show you the system that I use to build agents in Claude Code. This rule set is really important. These are basically the agent build rules. The value of this is that without rules, you're going to get inconsistent output where everything is different every time. It's less scalable as a result, and you can't hand it off or automate it. So ultimately the AI is fragile and things will just not scale, or the infrastructure can't run without you constantly overseeing it. So these are 8 rules for building agents in Claude Code. And the nice thing is that this is iterative. This can constantly be improved. But for example, we can look through some of these, like rule number 2, schemas. So schemas are essentially just a consistent structure so that every input and every output is structured. So without that, you can get an AI output that would be JSON one time or Markdown the next. Schemas ultimately are a way to get an understanding of what the AI will expect as the input and output, and therefore it's easier to catch problems before they might appear. Another one is these versioned prompts. What this is basically, like, every prompt in here is stored as a separate file and with version names, so it's not hard-coded. And this is valuable because you can update prompts without actually touching the code. And also you can track what changes. I'm non-technical, but this is something that developers would have. So they'd have versioning, and maybe in your SaaS tools, you can always go back in your publish history or change things. And that's the value of these version prompts. So if something does break, you can always roll back. So essentially you're treating your prompts in the same way that you would treat your software. Another one that is helpful, if we look through here, is one job per agent. So each agent must do exactly one thing, and you're not combining multiple responsibilities in agents. Same with if you're working with somebody and you have scope creep, it's harder to expect what the output is. In the same way with an agent, if your agent does exactly one thing, no multi-purposing, you're not expecting a Swiss Army knife of outputs. A single purpose agent is easier to test. A single agent is easier to debug, and then you can actually just layer on the different agents. So if we just take a look at an example agent, this is the AEO optimizer agent. So it is to optimize for answer engine optimization, to transform generated content into AI search optimized content. This agent was created by Claude Code, but it did reference everything that was in the build rules that I just showed you. So that is the value of having these build rules as a reference so that you can expect the agent to follow a certain structure. And once you have more structure, then of course, like I mentioned in the beginning, you have more consistency, you have more scalability, and ultimately more quality in the output that you can control over time. So the value of this is that I didn't write this manually, but Claude Code built it, and Claude Code did follow the rules that I was asking for. And so once you think about what the structure is, what your expectations are, and what you're looking to build, the specifications, AI can build to your specifications, and then that can cascade down into the other agents that you can build. So again, the takeaways are that you're getting consistency, you're getting the same structure every time, same quality every time, you're getting scalability. So whether it's one post or 10, or one client or 10, you're working from the same system, and it's faster, and you can also transport, or you can move from your system to another's. It can be deployed more easily, so handoff is also easier. So I think that this is really one of the key things that I've been learning, is the value of building systems and thinking about what those values are, or what those structures are upfront, putting them in, and then as you're getting the output, you can expect far better quality. So Claude Code is incredibly powerful for this because it's almost a forcing function for creating the systems and the structure that you need. So I'm going to start creating more content around this and sharing it. It can be intimidating up front, but I think breaking it down into bite-sized chunks and seeing how the system fits together, super valuable. See you around.